I know you don't got headphones in your ears, right? Because you're hearing me. We are doing this warm-up real quick, and you are also going to do some notes. So you need to be able to hear me. If you didn't take your test Friday, I'm going to, or I already did, talk to you about your test. So if you're testing on a Chromebook because you weren't here, or if you didn't start it, which is, we'll talk about your grade. But anyways, if you didn't, if you need to take your test, do that. Don't worry about these notes until later. You can catch up. Has everybody drawn these 6 figures? Okay. Let me back up a second. Virtual tutoring, still a thing. Make sure you let me know if you want to do virtual tutoring. You can get credit hours so you don't NC, and of course you can get some help. Okay, so there's that. It's in the evenings and also Saturdays. Let me know. We're gonna have a quiz on Wednesday, but not this Wednesday. Next Wednesday. So that's coming up. That's the next assessment. Make sure you turn in last week's warm-up with your name on it. Turn in anything from Unit 8 with your name on it, of course. We'll be updating grades, and after this test, I'll give you an updated progress report and make some parent phone calls. So make sure you're doing what you need to do, right? And being on time to class and everything, right? Okay. Now, you may have noticed these colorful things around the room. We're going to talk about that today, okay? We're going to talk about nets and 3D figures. This is the last unit. This is the final unit of the geometry school year. Cool? So again, we're talking about 3D. We've been in 2 dimensions this whole year. We've been all flat. But now, we've got the 3rd dimension, 3D, okay? So, if you didn't pick them up on the way in, I'm going to pass these out if you didn't already pick them up. We got notes and an assignment. Okay, so let me pass it out. Last couple seconds to get this warm-up done before I move the screen. So make sure you either have it written down already, or if you need to take a picture real quick, we're about to move on. All right. So we're going to start these notes. We are doing video notes. Okay. Make sure you follow along. Make sure you do not have headphones in because you need to hear what I'm saying, even if it's on this video. Okay. That way, when you get to the assignment, in which you're going to be looking around the room doing a scavenger hunt type thing where you actually have to get up. I know it's going to be crazy, but you're going to need to know what we're talking about. So make sure you are following along on the notes. Yep. All right, so first of all, the word solid. So obviously, hopefully you know from science what a solid is. Okay, it's something that's solid, right? But in all seriousness, solids are 3D, 3-dimensional, right? So we're not talking about those flat 2-dimensional shapes like squares and polygons. All that stuff's flat. We're talking about 3 dimensions. Okay, those are solids, and so that's what we're talking about here, this first blank, 3-dimensional figures, okay? And they're made of those flat things, those flat surfaces or even curved surfaces, right? So like a basketball is a solid and it's curved, right? Or a soda can is a solid, but it's curved, right? So you can have flat, you can have curves, okay? But I want us to underline this, make a big deal about this, okay? Each flat surface
is called a face. Okay? So if you're looking at these figures, if it's flat, it's face. Okay? Catch the F's there. Flat, face. Now, an edge is the segment that is intersection of two faces. So where two faces touch, it makes a segment, and that is called a edge. And then the corners, okay? Now, we don't actually call them corners, or we shouldn't. We should call them one of two things. If there's one of them, you call it a vertex. If there's two of them, you call it vertices, okay? All I want you to do is make sure you know that vertexes is not a word. Vertexes. Okay? So, vertices for more than one, vertex for one. All right? So, yeehaw, vertexes. All right, no, but seriously, vertices. All right, so it's all the corners. They're points, okay? So vertices are points, edges are segments, and faces are planes. Y'all remember that word from like first, second week of geometry? Planes, flat surfaces, right? All right, so moving down. So we're going to classify three-dimensional figures by the properties of the faces, edges, and vertices. 4 general categories of solids are listed below, okay? So, right here, first thing you got to know, a prism, okay? If you've ever seen, well, no. So a prism, it's formed by two parallel, congruent, polygonal, we'll say polygonal faces that are called bases, okay? So I want y'all to notice there's a thing called a face, and there's a thing called a base, and a base is a face, okay? So check that out. These two faces, all the flat surfaces are faces, but the ones that are on the bottom and the top there are called bases. Now, FYI, bases are not always on the bottom and top, because if you take that prism and put it sideways, the bases are still where they were before, right? So anyways, but they are the parallel bases. They're connected by faces that are parallelograms, okay? So check out what a prism looks like. It's got two bases that are going the same direction, okay? Next one, a cylinder, okay? Hopefully you know what that is. Okay, it's like a can-looking thing. It's formed by two parallel congruent circular bases, and then it says a curved surface. You notice how it doesn't say a curved face? There's no such thing as a curved face, because a face is flat. So, if you're looking at this cylinder, it's got two faces. Those two faces are also called bases, and the side is not a face because it's curved, right? What else we got? Pyramid. You should know what that word means, or at least what it looks like. A pyramid is kind of like a prism, except, do you see at the very top? There's a vertex, okay? So instead of having two bases, a pyramid has one base, right? So a pyramid is formed by a polygonal base and a triangular faces that meet at a common vertex, okay? So if we're looking at key important things, for a prism and a cylinder, for a prism, the faces on the side are parallelograms, okay? So it's connected by parallelograms. A pyramid, okay, is connected by triangular, okay? They meet at a common vertex. So the sides of a prism are parallelograms. The side of a pyramid are triangles. And then we got a cone. So a cone is formed by a circular base and a curved surface, which is not called a face, right? And it connects to a base, the base to a point we call a vertex, right? So these are your 4, if I can fit it all in one, yeah, there we go. These are the 4 different types of solids we're talking about today, okay? Prism, cylinder, pyramid, cone, okay? So, down here, a cube, okay, so at the very bottom of the front page, we have a specific type of prism. It's called a cube. So if you take basically a prism and all the faces are squares, every single side length, every edge is equilateral, well, then you get a cube, okay? A specific type of prism with 6 square faces. All right? And then as noted before, a base is a special face of the solid. More specifically, a base is a face. Base is a face. Cannot say this enough. Because some people think, well, if it's a face, it's not a base. No. Base is a face by which the figure is classified. Okay? So again, this is an important word, classification. What kind of prism is it? Look at its base. What kind of pyramid is it? Look at its base. Right? So the base tells you what kind of prism or pyramid you're talking about, okay? But cylinders and cones, it's always circles, so they don't have types. But prisms and pyramids have types. You look at the base, it'll tell you the type. Legit, okay? So if you can flip it to the back, here we go. Sorry. So, while cylinders and cones will always have circular bases, prisms and cones can have bases shaped like any polygon. As a result, prisms and pyramids are given a first name. Okay? So that's like what I was just saying. Prisms, pyramids have a first name. For example, okay? So let's look right down here. First of all, I have one base and it goes to one vertex. So everybody, what do I call that shape? A cone would have a circular bottom. So instead, a pyramid. I'm going to drop that over there in Egypt, and then y'all would think about it, right? No, but seriously, this is a pyramid. Now, here's the deal. I know it's write the word pyramid on the second little section. Pyramid, right? But I need a first name for my pyramid. What kind of pyramid? Okay? Now, you don't look at the sides. The sides are always triangles when it comes to a pyramid. You look at the base on the bottom. Okay? So I already outlined it, but what is this bottom shape with 5 sides? You got to remember. 2 units ago. What? Pentagon. Y'all remember that? Y'all didn't forget like a couple weeks back? So, pentagon. So here's the deal. When you name something, you put a little AL at the end. Pentagonal pyramid. Okay? Pentagon. Oh, that's kind of our way of describing it. Pentagonal pyramid. All right? Because its base is shaped like a pentagon and it has triangular faces on the sides. Yay. Okay. Off to the right here. The solid below is a, so. Now, does everyone see? I have this face connected to the same exact face over here. Now, it's not a circle, so I wouldn't call it a cylinder. What do I call it when there's 2 bases? Like that. What? 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 Who thinks they know? When I got 2 of the same bases connected by parallelograms. Prism, okay? Prism. That's where they lock up all the bad shapes. Get it? Got to go to state prism. Just kidding. All right, so now on the second blank, put a prism. That's fine, but what kind of prism are we talking about? So look at that base shape. How many sides do I have? 6. What do I call a 6-sided polygon? A hexagon. So what am I going to write? Hexagonal. Put a little AL at the end of that. Hexagonal prism. All right. And then let's look at the bottom 2. Okay. And here's our new word for the day, right? So y'all remember, let me finish reading this. It's a hexagonal prism because its bases are shaped like a hexagon and it has rectangular sides. Now, everybody, look right here. About to highlight again. Notice that even though the prism is resting on a rectangular face, the hexagons are still considered its bases. Do you see how this thing is sideways? The base is not on the bottom. That's the most confusing thing for people, okay? Because sometimes your prism is sideways, and your bases are not on the bottom, right? That's the base, still the base, okay? So, I just don't want you to freak out when that happens. Down here, here's our word of the day, because we're going to be doing that on today's assignment. It says a blank is a diagram. So, remember that word we were talking about earlier? All right, we're going to use that now. A net. Let's write that word down. A net. And Miss Marrero was talking about that test you might want to take one day. You're gonna see these nets. It's a diagram of the surfaces of a three-dimensional figure that can be folded to form a three-dimensional figure. Okay. To identify a three-dimensional figure from a net, look at the number of faces and the shape of each face. Okay. So you can kind of, in your mind, fold it up, which I know that's kind of abstract, right? It's kind of hard to do if you can't hold it in your hand. Now today you'll be able to hold it in your hand, kind of fold it up and see it, but in the future, maybe not so. So you have to kind of use your, not imagination, but you got to mentally visualize it, right? So, for example, the net below has two congruent triangular faces. So again, two faces. You should already rule out pyramid. Pyramid has one face, right? So whenever you see two faces, you're either thinking it's either a prism or maybe it's a cylinder, right? So what does it say? The remaining faces are parallelograms. Now if you need your notes, you look at the front. One of those things we talked about has two faces connected by parallelograms. What is it? Prism, okay? Now write that on the right side, prism, but I need to know what kind of prism are we talking about? So forget these three parallelograms. I want to look at my two bases. What's this base and this base? What are they? Triangle, right? Now, I'm going to change the end of this. So instead of triangle, don't say that, okay? It's triangular. Triangular prism, okay? So let's write that down. That's the only exception to the rule. Triangular prism, okay? Over here, on the right, the net below has one square face. Now, when you have one face, remember, that eliminates prism, and it eliminates a cylinder, okay? One face is either going to be a pyramid or a cone, right? So what we do is we ignore the triangles, and we think, what's that base? A square, okay? So this is, what kind of pyramid is it? A square pyramid. So there's actually no extra little letters on that. It's just square pyramid, okay? Cool. All right. So here's what we're about to do. If I can find it here. We are going to get some practice with some nets. So I'm going to give you this sheet. It says 3D Nets recording sheet. Okay. There are 11 different nets that you need to be able to see to do this assignment. So I tried to space them out all throughout the room. So if you don't like standing, we don't do it every day, just do it with me today, right? So you're going to actually have to get up and go around and look at the shapes, right? So there's some in the front, some in the back, some on the side, okay? So you're going to actually have to get up. You can't, it's not something you can necessarily take a picture of, okay? But what you're going to do is you're going to tell me the name of the base, name of the whole figure, how many faces, how many edges, and how many vertices, okay? So if you get stuck on that, you know, you can always ask us. And then there should be a back to it where you're going to name that net, kind of like what we were doing on the notes, okay? be very careful when you're doing this. If you're not sure, ask questions, okay? But you got the rest of class to finish this up. I'll let you get started right now. So you may rise to the occasion. And you can start on whichever one you want, okay? You don't have to start on number 1. In fact, don't, because then we'd have too many people, okay? So start, make sure you look at the number that's on the shape. That'll tell you where you're recording it, okay? So let's get started, please.